Okay, welcome to the last video in this chapter 1 of linear relations. This is 1.3. It will go from pages 55 to page 77, and we'll be talking about scatterplots and linear trends. All right, before we continue on to understand what this chapter is about, this part of the chapter is about, we need to understand a few definitions. We need to know what a scatterplot is. We need to understand what the definition of the word correlation means, line of best fit, and outlier, okay, to do this chapter. Well, basically what a scatterplot is, it's just a graph of ordered pairs used to evaluate what type of relationship, if any, that exists between two variables. Now, if you look at what I've got on the screen here, I have a snapshot of page 56 of your workbook, and I've got 4 graphs. Graph A, B, C, and D. Each one of these graphs are scatterplots, and you just can look at what the graph looks like and you can say that it is a scattering of a whole bunch of individual points plotted on a graph. Okay? We need to know what the word correlation means. So on page 55 you can see some definitions. The word correlation in the right hand column just means the degree of relatedness between two variables. In other words, we've got each one of these points is a variable, and is there any relationship between them? Underneath correlation we have the word line of best fit, and the definition of that is simply a line drawn on a scatterplot to show a general trend in the data. Now we know what the word trend means. The word trend means, is there any specific pattern, okay, or grouping that these points follow? And then we need to know what the definition of the word outlier means. Outlier basically is just a data point that lies significantly outside the general trend of the data, basically an outcast of the group. Okay, so knowing those 3 definitions and what a scatterplot is, we can now look at these graphs of scatterplots and we can analyze them. Okay, see if there are any trends, any patterns, anything that we can interpret from those specific kinds of graphs. And we want to ask ourselves the question when we're looking at these types of graphs called scatterplots: what is the shape? Is it linear or is it nonlinear? The strength of the graph, is it weak or is it strong? The direction, is it a positive slope or is it a negative slope? And are there any outliers on the graph? Okay, so for each one of these 4 graphs, we're going to answer a few questions about them. We're going to find out, is it a linear or is it a nonlinear graph? Is it direct or is it partial? In other words, does it go through the origin or does it not go through the origin? What is the direction of the correlation, if any? Does it go left, right, up, down? Is a straight line? Is it a curved line? What's the strength of the correlation? Is it strong or is it weak? Does it show a definite trend or a definite pattern, or is it all over the place? And are there any outliers? Okay, so let's look at the first one, graph A here. And what we want to do when we look at this data is we want to determine what we call a line of best fit. So what you're going to want to do when you're drawing a graph like this is you're going to want to have access to a ruler or a straight edge, and you want to be able to look at the information, look at the data plots, and you want to see if they follow any specific trend, and can we draw a line through that data that kind of follows that trend. Well, if we look at this particular graph, we can see all these points on here are basically following an up and to the right trend, basically a positive slope, and they're kind of following a typical pattern of a straight line up in that direction. So if we want to draw what we call a line of best fit, we kind of want to draw a line between the data points with about maybe half the points on one side of the line and half the points on the other side of the line, and see what direction they're going and see what pattern they're going to follow. So if I'm following this line going from here down to here, I can pretty much guess that it's going to go through the origin right here, which means it's going to be a direct linear equation. And if I'm going to draw a line, I would take my ruler and I would draw it through, place that ruler, the straight edge, through those points, probably wanting half the points on one side of the line and half on the other side line. So it really helps if you've got a transparent ruler, so you can see the points underneath it and above the line. And I would say that probably a line of best fit would be somewhere through there. Now my line is not very straight. It's supposed to be a straight line. You'll have a ruler. I don't have a ruler on my board here. But we can probably see that if that's a straight line, this would be the general trend. The general trend would be up and to the right, which means it's going to be a positive slope. Okay? Positive slope means a positive correlation. Now the points are very close together, so the correlation we could say is strong. That's how we could describe this correlation, as strong. Okay? And when I look at this type of graph, I don't see any outliers at all. So I could write down here, no outliers. Okay, so this graph shows a strong trend, a direct linear correlation, sloping positive slope up and to the right with no outliers. Okay, so let's just scroll down to graph B, and let's look at the information we have on here. Now when we look at all these points, we can see, well, they're not as close together as graph A, but they still show a general trend if I was to draw a line of best fit through them. So you have to take your ruler, and I'm going to just kind of maybe guesstimate where this might go. Now it does seem to follow somewhat of a straight line, so I'm going to basically put a line maybe starting here. I'm just going to kind of guesstimate and maybe follow down to, oh, maybe about here. That seems to be a decent direction for a line of best fit. Somewhere down through here. Okay. Now we need to look at this and ask some questions. Is it a direct linear relation or is it a partial linear relation? Well, we know that it's not a direct because it does not go through the origin down here. So I can say that this is a partial linear relation. Okay, it does form pretty much a straight line. Okay, does not pass through the origin. Okay, now the direction of the line, it goes down and to the right. So we know that that is a negative slope by going down and to the right. Now the points are spread out a little bit more than the graph on than graph A. So graph A, we said, was had a strong correlation, a strong trend. This one here, the points are a little bit more spread out, so we might want to just describe this as having a moderate correlation. Okay, now the trend is pretty much a straight line, negative slope, moderate correlation. Okay, and then the last thing we want to look for are outliers. Well, here's my line right here. I'm kind of tried to get about half the points on one side of the line, half the points on the other, kind of going through the middle of the data. And then it looks like I might have a couple of outliers. This might be an outlier piece of data, and this might be an outlier piece of data, kind of not following the trend. So those are the types of data that you'd want to basically ignore, and that's why we call them outliers or outcasts. Okay, so on outliers, we have 2 points that are outliers, 2 points that are outliers, and we might want to label those. Okay, might want to maybe identify them, and if you look on page 57 of your workbook, you can see that one is x value of 1.2 and 1, and the other point is 4 and 5. So you might be asked to label the outlier point. So this is how you would do it. You would just write it down as a coordinate. All right, so let's go down to C. C is a different kind of scatter plot, and if you look at this particular scatter plot, you can see that the points are really scattered. Kind of no trend, no correlation at all. No relationship between the variables. They're all spread out, and there doesn't seem to be any apparent trend. So what we could do is we could say there's basically no apparent spell it right, no apparent trend in the data. Okay, spread out all over the place. Okay, so we can talk about outliers, but basically every point could be an outlier because there's no basic trend. So there's really no analysis that we can make, no conclusion that we can draw about this particular type of graph. We can't find any correlation, we can't find any trend, we don't know if the slope's positive or negative. It's just data is just plotted all over the place, and it's really, really hard to interpret this kind of a graph. Okay, so basically all you need to do to describe this is just write down there's no apparent trend. So that takes us down to the last one, which is this graph right here. Now this is an interesting graph because if we were to look at the first two way up here, we can pretty much, we're drawing our line of best fit. You can see that we drew a straight line there and we drew a straight line there. That's kind of the trend of those two graphs. If I look at the last one here and I was going to draw a line of best fit, it doesn't really seem to follow a straight line. Doesn't mean we can't draw a line of best fit. It just means that it's going to follow the data on here. And so my line of best fit, again, I want half the data points, the plots on one half of my line and half on the other side of the line. So I'm going to kind of draw it like that. Now we know that this is not a line. This is a non-linear type of graph, not a linear graph because the line is not a straight line, it is a curved line. Okay, so if I was going to describe this one, I would describe this as a non-linear graph. Now let's look at the correlation. Just because it's non-linear doesn't mean it doesn't follow a positive or negative trend. You can see that it goes up and to the right, so we can say it still follows a positive trend or correlation. Okay, the points are quite close together, so we could say that it has a strong trend. Okay, and the last question we want to ask, are there any outliers? And I don't see any outliers here or here, so we could say no outliers. So basically what this chapter is, it's just going through different graphing scenarios where you'll have to analyze scatter plots. You're going to have to draw your own scatter plots from different examples. There's lots of them on there, lots of practice for you to do to build your skills. And then when you're done this chapter, this part of the chapter 1.3, you're done the chapter, and you can write the 1.3 quiz. And at the end of 1.3, towards the end, we have the chapter test, starting at page 72, going to page 76, which is going to cover everything on chapter 1, from 1.1 all the way up to 1.3. You're going to want to do that. So once you've done 1.3, do the chapter test, or you might want to do the chapter test first, then do quiz 1.3, and then you are ready to do the chapter 1 unit test when you feel that you've mastered this material. Okay, well, good luck, and let's get all this stuff done.